Hello and welcome back to Clean Code. Today's question comes to us from Spotify. And Spotify asks us to find the top ranked songs for the last 20 years. And we're going to do that by finding all the songs that were top ranked at the first position at least once in the past 20 years. Looking over our data table, we can see we have a bunch of columns: year, year rank, group name, artist, song name, and ID. If we go ahead and quickly run the code and see what our data looks like, we can see year, year rank, group name, artist, and song name all look like they will be important for us to be utilizing. ID looks like it's going to be a connector or a foreign key for a different part of our data, and we can probably ignore that for now. All right, now that we have our feet squared, let's go ahead and jump into problem solving. All right, welcome to the notebook. Let's go ahead and highlight the key components of this question. It's going to be all the songs, first position, and past 20 years. I think those are our keywords that are trying to clue us in on how to approach this particular problem. And with this particular problem, I think we're going to be able to leverage some in-house PostgreSQL functions. Primarily, I think we can use distinct. And I always forget how to spell this. I think that's right. And then we also are going to need to use and extract for our date. That's where that year is coming from. We want to extract the years. Okay, let's take a quick look at our data and let's try and highlight the parts that we're going to need to use. We're going to need to use song name because it asks for the song, not the artist, the song. So artist and group name may or may not be important. We definitely are going to need year, and we definitely are going to need to use year rank. So suddenly, the 6 columns, there are actually 3 columns that we need. There's some false columns there waiting. So let's now take a minute and kind of think of our plan of attack. We know we need to select this distinct song names. That's probably going to be step 1. So we'll jot down song names. Step 2 is we're going to need to find rank equals 1. And step 3 is going to be past 20 years. Now, I got a question last time in the DMs. Why don't I write full steps out? Well, for the very helpful reason that I try to showcase this kind of problem solving so that when you're doing this live in an interview, you have a framework that you can use. Now, I don't write down the full steps because I have to keep a dialogue going to showcase my thought process for my interviewer. So the plan of attack notes, it's only in case the interviewer interjects and asks a question and we have like a tangent, and then I need to come back in 40 minutes, I got to solve 6 problems. And if we have a tangent and I have to jump back to what I was doing, it takes brain power to do that. And that's why we have the plan of attack in a shorthand, so that if I am working, got my sheet of paper and I'm working, I can quickly look over and see, okay, I need to finish step B. Step B is find rank 1 and hopefully get the brain back on track. Okay, that being said, let's try and go back to the code editor and we will code up a solution. All right, now that we're here in the code editor, let's go ahead and use our plan of attack to finish this problem off. We're going to select distinct song names because we're discriminating based on year, and there is a possibility that one song could have multiple years as a number 1. We're going to pull our data straight from the table. I mean, that's there's no other way to do it really. And then we're going to, in one line, get page rank 1 and our date. And we're going to do it just like this. We're going to use that AND function to have 2 separate conditions, and we want to make sure our year is greater than or equal to, and then we're going to extract from the year from the current date, and then minus 20 off of that to get that 20-year window. And that saves us the hassle of having to use date manipulation in SQL, a sliding window, or a CTE, or any other kind of more advanced methodology to solve this problem. I think it's pretty slick. Go ahead, run our code, make sure everything works. Looks like it's all good. Execution time nice and fast. That'll make the data engineers happy. We go ahead, we get the green button, all greens, problem solved, and we're moving on in interview. Okay, stick around for after hours if you want to have a more in-depth breakdown of how all this code is working. Otherwise, I've been Clean Code. See you next time. All right, everyone, welcome to After Hours. Let's go ahead and break down this code a little bit more in depth. So here in line 1, we're using select distinct. Now, select obviously is one of the 3 core functions of SQL. You kind of have to use it every single time. But the distinct function is kind of has a built-in ability to just go and extract unique values from your data. So if you think of your data as a big box, like I do, what we're saying to the code is, hey, pull out all the unique song names. So we pull out all the unique song names and it's holding it in its hot little hand. And then we say, okay, where do we want to pull it from? Obviously, we kind of pull it from our table. Not a whole lot going on there. But where I think most of the novelty in this solution comes from this where statement. So where is putting a condition. We're putting a conditional on being able to come be a subset from our big data table. And that conditional is year rank equals 1 and this is the one where I think a lot of people will have a little bit of trepidation in understanding, year is greater than or equal to the extracted year from the current date minus 20. Now, the thing that might be a little non-intuitive is these 2 years are different. This year right here corresponds to this year in our table. But this year right here comes from the current date function, which is pulling from your system clock and only extracting the year. And from that extracted year, we're going to take off 20. So we're greater than or equal to 20. So that's where I think there might be a little bit of confusion. This year comes from the system clock, and this year comes from our data table. Other than that, it's a relatively straightforward piece of code. Go ahead, comment down below if you have further questions, and we'll get someone to answer you. All right, until next time.